Hey guys, this is Mr. Sal. We're going to look at a quick lesson on writing equations using symbols. What is the coefficient of x in the following expressions? Number one, oh by the way, a coefficient is stuff you guys learned in 7th grade, and we're going to be using this vocabulary actually quite a bit, not only today but throughout this whole unit. A coefficient is just a number that's being multiplied by a letter, so on number one, that would be -5. On number two, most of you guys would say this is 13, but it's a term. That would be -13 because it takes the operation immediately to its left if it's addition or subtraction. Number three, that's a +6. And then number four, once again, we're looking at the full term. So the actual coefficient of x on this one would be -72.4. All right, take one moment and write down the objectives. Don't worry about the standard, that's already on your paper. The first one, I can define a variable for an equation. And the second one, I can write an equation based on the variable from a word problem. Let's look at some key vocabulary. We won't see all of these today, but it's possible we'll see them in the future. So let's go over these. Consecutive, the first one there. Consecutive is just where we take one term after another, but in some kind of order or sequence. And then the sum, that would be the answer to an addition problem. And then the difference would be the answer to a subtraction problem. Does anyone know what operation the quotient is?
Multiplication.
It's close. So then finally the product would be the answer to a multiplication problem. Those ones are pretty common. You guys should have used those extensively in the past. Let's look at a solution. Solution is a value for an equation that makes the equation true. We're going to say that a little bit differently because we're going to be using x for the most part. An equation is where we have two expressions that are equal. Now, if the two expressions are not equal, then there would be a non-equation, an inequation, but more formally an inequality, which we're not covering yet. But for now, we do expect these to be equal. Otherwise, we're just going to state that they are false. All right, write each of the following statements using symbolic language. So we just want the equation on this. Number one, the sum of 4 consecutive even integers is -28. So let's define our unknown on this first, which is, for us, is going to be x. And I'm going to say x is the smallest of the even integers. So an integer is just a whole value that's either positive or negative, but it could be 0 as well. All right, if this is the case, let's read this again, and some of these we may have to read several times. It says it's the sum, so what operation are we looking at for this?
Addition.
Yeah, it is addition. So since it's addition, how many numbers are we adding together? Well, it says 4. 4 consecutive even integers. All right, since we're adding 4 numbers on this, I'm going to have one number added to the next one, added to the next one, added to the next one. And that's how we're going to start this thing. All right. So let's start with the smallest even integer, which for us in this problem is x. Now these are even integers, so how much bigger is the next even integer than our smallest even integer? Well, if we went to the next one, that would be odd, so we've got to go one more. That means we're going to take that smallest even integer and add 2. And that would give me this next even integer. But then we got the next one, which would be the smallest one. And now instead of going up 2, we've got to go up 2 more. So I've got to add 4 to that. And then I've got my next number, which would be the smallest number, but now I've got to go up even 2 more. So I've got to add 6. So this just takes care of the part of the problem that says the sum of 4 consecutive even integers. But then it says that it is, so that's equals, is -28. And that's all we want. There's no need to solve this thing, even though some of you could. For now, that's all we need. Don't forget that the definition of x is part of the answer for this thing. Let's look at number 2 then. A number is 4 times larger than the square of half the number. Take 1 minute and do this with your neighbor. All right. So what is it about this problem that we don't know?
Everything.
Well, for some of you, it may be that way. But for us, right now, just by reading this, it appears that it is the number or a number. So x will represent the number. X is the number. And then it says a number. Well, that's x for us. Then it says it is. So that's our equal part. Generally, when we see is, it represents some kind of equal sign. Then it says that it's 4 times larger. So whatever it is, we're going to take 4 and multiply it by whatever it's 4 times larger than.
16.
Specifically, it says it's the square. Square is an exponent. And this one then says it's half the number. Well, half the number would be the number, but then we're going to cut it in half. So we'll divide it by 2. Now this is a fraction with an exponent, so we do need, just like we talked about in module or unit 1, we do need parentheses on this.
That's the problem.
That's it. Now right now with what we know in 8th grade, we're not able to solve this yet, but you will in 9th grade. Number 3, Stephen has some money. If he spends $9, then he will have 3/5 of the amount he started with. Take a moment and write the equation for this one with your neighbor. Stephen has some money. If he spends $9, then he will have 3/5 of the amount he started with. Remember in this class, if you guys are just waiting for answers, you're kind of defeating the purpose of the class. That's not really how you're supposed to learn here, okay? So, on this one, once again, we do need to define our x value, which is whatever we don't know on this. Now, it does say Stephen has some money, so it is certainly Stephen's money. But actually, that's not enough to fully define this, because at the end of the problem, it says of the amount he started with. And also, he's spending $9 from the money he starts with. So we need to be more specific on that. It's Stephen's money that he started with. So, again, I'm worried you guys are actually solving these. We're not trying to solve them, even though I know you guys could. So on this one, we're going to start with Stephen's money, which for us, we don't know how much that is, that he started with anyways. But then it says that he spends $9. How does that affect the money he started with? Very good, it takes away. So what operation is that? Sorry? Subtraction. So we're going to take the money he starts with and subtract $9 from that. But then it says he'll have 3/5 of the amount. So 3/5 of the amount he started with, which for us is x. So we're gonna, if we multiply 3/5 by the money he started with, that would tell us how much money it would be for him taking away $9. Well, there's one more thing on this. We're supposed to be writing an equation, so there's the equal sign that's missing. And it says it's the same thing. If he spends $9, it's the same thing as having 3/5 of what he started with. So these two are equal. Now again, it's not required that we solve this, even though this one you guys would be able to. Number 4, the sum of a number is squared and 3 less than twice the number is 129. So the first thing we should do on this one, just like we did with the others, is define our unknown. And on this one, the thing that we don't know is a number, or it says the number. So a number is less writing, so I'm going to do that. A number. X equals a number. Well, then it says it's the sum, and we've already seen that the operation for sum is addition. So we know we're adding two things together. Specifically, it's a number squared. So I'm going to take our number, which we don't know yet, which we'll say is x, and square that. And then what am I adding to this? It's 3 less than twice the number. So this means I've got to take twice the number, so 2 times the x, and it's 3 less than that, so then it would be subtract 3. Now we can think of this in terms of real numbers, such as if you had 3 less than $10, it would be 10 minus 7, 10 minus 3, which is 7. So it's the same thing here. It's 3 subtracted from 2x, or 2x minus 3 as we have it written. And then it says that it is, so there's our is word, which is the equal sign, and the number is 129. Now again, this problem we haven't learned how to solve yet either in 8th grade, but in 9th grade you will. Number 5, Miriam read a book with an unknown number of pages. The first week she read 5 less than 1/3 of the pages. The second week she read 171 more pages and finished the book. Write an equation that represents the total number of pages in the book. Take 1 minute and see if you can write this equation with your neighbor. Now don't forget to define your variable first. So here's what we got on this thing. First we'll define our variable, which for us we'll say is x. X would be the number of pages in the book. So if that's the case, there's 2 things we see on this. We have the first week and then the second week, and then she finished the book. So let's write that out. This is kind of help us set up the equation. All right, now again, this is just to help us set it up because we know there was only 2 weeks that she read the book and then she finished it. So in the first week, what does it say? It says she read 5 less than 1/3 of the pages. So for week 1, it's 5 less, so we're going to subtract 5 from something, and that something is 1/3 of the pages. So it's 1/3 of the pages, so we got to take 1/3 and multiply it by the number of pages in the book, and then we would take 5 pages off of that. So she almost reached 1/3 way through the book in week 1. In week 2, it says directly that she read 171 more pages. So in week 2, she read she read 171 pages. And we see when we add these two together, we get the total number of pages, which for us is x. So we've defined our variable x is the number of, or total number of pages in the book, and then we have our equation there. That's all we need for this problem. Write each of the following statements using symbolic language. So we're just writing the equations for these, not solving them. Okay. Number 1, Bruce bought 2 books. One book cost $4 more than 3 times the other. Together the 2 books cost him $72. So here's what we're going to do on this one. First thing we need to do with all of these is to define the variable. And we're always going to be using x. And x represents what we don't know, which, alright, we're going to say that looks like x is going to be the cost of the cheaper book. And how do we know that? Because we got 2 books, and one book is $4 more than 3 times the other book. So that one sentence right there is based on the cheaper of the 2 books. So, just based on this one statement, one book cost $4 more than 3 times the other book. Means I've got to take 3 and multiply it by the other book, which would be the cheaper of the 2. And it's $4 cheaper than that. I'm sorry, it's $4 more than 3 times that, so we've got to add $4 to that. Now that's just the cost of the more expensive book. But then it says together the 2 books cost $72. So that means if I add the cost of the cheaper book, then it would have costed $72. Now you guys could solve this, but again, we're not interested in solving it right now. All we're worried about is writing the equation for this. So that would be the final answer for this one. Janet is 3 years older than her sister Julie. Janet's brother is 8 years younger than their sister Julie. The sum of all their ages is 55 years. So here's what we know to start out with, is if we take Janet's age, Janet plus Julie's age, and then add it to the brothers, we'll just put brother, then we get 55 years. But it doesn't really tell us directly what the unknown is. However, Janet's age and the brother's age is based on Julie's age, so we have to let x equal that value. So x would be Julie's age. Now what we have in the start there is just to help us set this up. Janet's age is 3 years older than Julie's. So we've got to take Julie's age, x, which we don't know yet, and we would have to take 3 years older than that, so we're going to add 3. Julie's age is just x, because we don't know it. And then the brother's age is 8 years younger than Julie. So the brother would be Julie's age, but 8 years off of that. So x minus 8. When we add these three values together, we've already seen that the sum of their ages is 55. So this is the equation here. And we already have defined the x value for us. All right, take 1 minute with your neighbor and try number 3. The sum of 3 consecutive integers is 1,623. Go. The sum of 3 consecutive integers is 1,623. So we've got 3 integers and it's a sum. So we've got to add these together. So I know I'm going to be adding 3 values, 1, 2, 3. And then we just fill in the spaces with whatever we get on that. Since we have 3 consecutive integers, integers are whole values or they're negatives or opposites. So I'm going to say x specifically is the smallest integer. Well, if x is the smallest one, now these are straight consecutive integers, then the smallest one would just be x. The next integer would be the smallest one, but it would be one more after that. And then I've got a third integer, which its relationship to the smallest one. It's not one bigger now because it's bigger than that second value. It's got to be 2 more than that. And then this says that it is, so that's equals 1,623. Now again, I know you guys could solve this, but it's not required that we do right now. So that's how we're going to leave it. All right, number 4, one number is 6 more than another number. The sum of their squares is 90. Take 1 minute and see if you can write that equation and define the variable with your neighbor. So since one number is 6 more than another number, and then the sum of their squares is 90, I'm going to say that x, it's either got to be one of the 2 numbers, and one's bigger than the other. I'm actually going to say, though, that x is the smaller number. So if that's the case, one number is 6 more than the other number, so that means it's the larger of the 2, and the sum of their squares is 90. Okay, so the one number would be the smaller number, but 6 more than that, and that's the one number. The smaller number is just x, because we don't know what it is. But then it says the sum of their squares is 90, so that means I've got to take these, square them. You don't need parentheses on just the x, but you can. And it said it's the sum, so I'm going to add those together. And then that sum is 90. So this would be the equation for it. Again, it's not required that you have the parentheses around the x, but you can if you want. Be careful, some people in the other classes were getting the square mixed up with the square root. So it's not that it's a radical, it's just a straight square on that. All right, if there are no questions, number 5, when you add 18 to 1/4 of a number, you get the number itself. Take 1 minute and write the equation for that one. So on this one, it's a little bit more direct on what it is we don't know for us to define our x value. It's just the number, or a number. So we're going to write a number. X is a number, which we don't know. Well, right here it says if you add 18, so whatever it is, we're going to add 18 to it. And that number we're adding 18 to is 1/4 of the number. Well, that'd be 1/4 of the number, means we'd have to multiply it by the number we don't know, which is x. Then it says you get the number itself. Well, that would be equal to the number, which we don't know, which is x. And that would be the equation. So again, we've defined the variable and we have the equation. Yeah, so if you did that 1/4 as the number, but 1/4 of it, that also works, instead of 1/4. Number 6, when a fraction of 17 is taken away from 17, what remains exceeds 1/3 of 17 by 6. Take 1 minute and see if you can write the equation for number 6. So it's a fraction of 17 is taken away from 17. What remains exceeds 1/3 of 17 by 6. What it is right here that we don't know is apparently the fraction. It looks like it's a fraction of 17, specifically. So we have to find our x. It's a fraction of 17. So when a fraction of 17 is taken away from 17, that means I'd have to take the 17 and subtract the fraction of it. What remains, or what is, would be 1/3 of 17, so I'd multiply that by 17. But it exceeds that by 6, so I would have to add 6 to that. That's the equation with the defined variable. So the sum of two consecutive even integers divided by 4 is 189.5. So we've done x as a smaller number before, so I'm going to say in this case x is the larger of the two, because it wouldn't matter. Or integer, it's not going to make a difference. Now it does say it's the sum of these two consecutive integers, which means of these two numbers we're going to be adding the two. And I'm going to start with the smaller number. The smaller number is the larger number, but since it's an even integer, it would be 2 away but 2 below it. Because it's an even integer. And then we would also have the actual larger number, which would just be x. And then it tells us that this is 189.5. And that's it. Again, we don't need to solve this because it didn't ask us to. We just needed to write the equation for it and define the variable, which was part of the objectives for this lesson. All right, number 8. Subtract 7 more than twice a number from the square of 1/3 of a number to get 0. Now again, we may have to read these several times. Let's look at this again. Subtract 7 more than twice the number. This tells us to subtract. We're subtracting all of this stuff from the square of 1/3 of a number to get 0. So looks like it just says it's the number, which we don't know right now. So I'm going to say for this one that x is the number. All right, so let's put together 7 more than twice a number in green there. So that's twice a number, but 7 more than that. And we're going to subtract that from the square. Let me move that over. All right, we are subtracting this from something, so we're going to have to take all of it and subtract it. Specifically from the square of 1/3 of a number. So let's see, let's look at the 1/3 of a number stuff. So I'd have 1/3 of the number, which is x, and we're going to take the square of that. And when I subtract that 2x plus 7, which is 7 more than twice the number, then it says that we get 0. So all of that would equal 0. And that would be the equation for this word problem. Again, that's all we need for that part. Number 9, the sum of 3 consecutive integers is 42. Let x be the middle of the 3 integers. That's okay. Transcribe the statement accordingly. All right. So they've already defined x for us. X is going to be the middle number. And integers are whole values, so they're just one away from each other. And it did say it was a sum, so I'm going to add these 3 values together. And x is the middle number. So if I wanted the number before it, I would take that middle number and I would subtract 1. If I wanted the number that's just bigger than it, I would take that middle number, but I would add 1 this time. Then it says that this is 42. So that sum would equal 42, and that would be the expression for this one. So again, we've defined it. X is the middle number, and then we have our equation. So now that we've reached the end of lesson 1, you should be able to define your own variables for an equation and also write the equation based on the variable from the word problem. Alright, so that concludes the lesson. Thanks for watching. And don't forget to like, comment, and subscribe.